Okay, so this problem is very similar to MVF F2. It's just that there's a different time, and again, that makes it look a lot like that scene from the Indiana Jones movie, the first movie, Raiders of the Lost Ark. So here's the idea at a particular time. If you're at some point, let's say, and I'm going to draw the coordinates of the point by sort of exaggerating its position a little bit. So there's a point. I want to know, where does the shadow get cast? Well, it gets cast, now it depends on where the sun is. The problem says that the sun is in the theta equals 0 direction, so the sun is way off over that way, but it's angled up. What's that, pi over 6, because this angle here, sort of the angle off of the vertical was pi over 3, so that makes this angle pi over 6. So I claim, I'm going to appeal to your geometric intuition, that the cast of the shadow, and so you could think of this as being like the shaft, and there's the jewel, right? And the shadow that it gets cast, kind of like this, and it goes to some point about like there, right? And here's Indiana Jones. And that's the jewel, and that's where the arc is on the map. Okay. Is everybody okay with the picture? All right. So let's keep in mind this point here is x comma y comma z, and I just want to know what are the x and the I want to know what are the x and the y coordinates of that point. So good news, this is the y-axis, so it's really easy actually to find what the y-coordinate of that point is. The y-coordinate of that point is the exact same as the y-coordinate of this point, which is the exact same as the y-coordinate of that point. In other words, it's just y. That's sort of easy. Okay. And let's see, so let's call that, this is x, because this point here, this is the x-coordinate of that point, which is the same as the x-coordinate of that point, so that's just x. The shadow is going to have a particular distance there, and I claim that the x-coordinate of this point is just x minus d. We don't know what d is yet, but whatever d is, that tells you how much you're going to subtract off of the x-coordinate of the original point. Is everybody on board with that? Yeah.
I don't understand how D relates to X in the diagram.
Yeah, well, we don't know what D is yet. That's right. I mean, we're going to have to do some work to figure out what that D is. But so the idea is that, so D says, this point here has an X coordinate. And D says, how much are we going to change that X coordinate? Because it's the distance from here to there. Does that make sense? So once we know what D is, and there's some effort that goes into that, that's what we subtract from the x coordinate of this point, namely x, to get the x coordinate of that point. Okay, so we're good. So, all right, well, shadows cast by particularly rigid physical rules, right? Namely, the line of the casting of the shadow is parallel to the line that's pointing to the sun. I mean, if that's where the sun is, then that's got to be parallel to that. And I didn't draw that very well, it would seem. But these are supposed to be parallel. Does that make sense?
Okay, parallel.
Yeah, this little dotted line here is supposed to be parallel to this. That's the direction the sun is in. In other words, shadows get cast radially from the sun, in other words. So what that tells me is that angle there is pi over 6. And, of course, that's a right angle because he's holding the staff upright, presumably. And that makes this pi over 3. So this is a 30, 60, 90 triangle. And let's see here now. We have some information about, let's see here. Yeah, so the height is at z. So this distance there is z, and it's a 30, 60, 90 triangle. So that makes that square root of 3 times z. So I'll say z square root of 3. Does that make sense to everybody? So altogether then, here's our answer, our S4 function. So this is the shadow function, at 4 o'clock. In other words, at the time when phi is pi over 3 and theta is equal to 0. So at that particular time, the shadows of points at locations like x, y, z, the shadow is going to be at x minus d. D was this, z square root of 3, comma, y. There you go.
Okay, so the intention was not to write that in spherical.
No.
For some reason that's supposed to be.
Yeah, no. Well, I mean that's right. I mean the problem has phi and theta referred to in the problem, and it kind of makes it look like a spherical coordinates problem. But no, what we wanted was just the rectangular coordinates, and the reason I used those spherical coordinates was just I needed to describe the direction of the sun, and spherical coordinates are just really convenient for that.
Okay.
Yeah. Anybody else?
How did you get how did you get the?
Oh, okay, yeah. So I claim that this triangle here, this is what we call a 30, 60, 90 triangle. So the sides are in proportion like this. So 2, 1, square root of 3. This is what a 30, 60, 90 triangle looks like. And so what that means is that this side, the D, is square root of 3 times that side, which is Z. Yeah. So similar triangles. Yep. Okay. Any other questions about this problem?